Our universe is brimming with energy and vitality, evident throughout the vast expanse of space. We are constantly witnessing magnificent and intense cosmic events. Among binary star systems, two of the most well-known and spectacular phenomena are novae and supernovae. Recently, astronomers have identified a new type of stellar explosion, which they've termed micronova. This discovery not only marks a new chapter in astronomical research, but also challenges our current understanding of the thermonuclear explosions that occur within stars. In ancient Chinese history, the sudden appearance of stars in the sky was documented quite early. These stars would typically flare up brightly for a few days or months before gradually fading away. Today, we understand that these events were likely either novae or supernovae. In the West, the term nova originated in the 16th century. In 1572, the astronomer Tycho Brahe observed a supernova explosion in the constellation Cassiopeia, now known as SN 1572. He described this phenomenon in his work De Nova Stella, and the term nova has been in use ever since. For centuries, the terms nova and supernova were often used interchangeably. It wasn't until the 1930s that scientists truly began to distinguish between these two phenomena, recognizing the significant differences in their causes and the amount of energy they release. A nova is not a new star in the literal sense. Rather, the term refers to a powerful energy release event occurring on the surface of a white dwarf. White dwarfs are stars in their final stages of life, possessing a mass similar to our Sun, but compressed into a size comparable to the Earth. In binary star systems containing a white dwarf, if the distance between the stars is close enough, the white dwarf can siphon matter from its companion star. This matter is primarily hydrogen. As this gas is drawn towards the extremely hot surface of the white dwarf, it creates the conditions for a powerful thermonuclear reaction, leading to a nova event. When hydrogen atoms are pulled onto the white dwarf's surface, the intense temperature and pressure trigger nuclear fusion, transforming hydrogen into helium. In normal stars, these reactions occur deep within the core. However, on a white dwarf, they take place on the surface, creating an effect like a colossal flare that causes the star to brighten dramatically for several weeks. A single white dwarf can experience multiple periodic nova explosions throughout its existence, which can span millions of years, as it continues to accrete matter from its companion star. Some white dwarfs become increasingly massive as they accumulate more and more matter. Consequently, the nova explosions become more frequent until the white dwarf reaches the Chandrasekhar limit, the maximum mass a white dwarf can sustain while remaining stable. Exceeding this limit can lead to a Type Ia supernova, an incredibly powerful cosmic event. Recently, a team of astronomers, while analyzing data from the Transiting Exoplanet Survey Satellite TESS and the Very Large Telescope VLT, discovered some unusual phenomena. Mysterious explosions from white dwarfs that lasted only a few hours but produced brilliant optical light. Given their similarities to novae, but on a smaller scale, the scientists named them micronovae. Compared to typical astronomical phenomena, micronovae are much smaller in scale, releasing far less energy and unfolding more rapidly, often within just a few hours. Further research revealed that these micronovae occur on white dwarfs with strong magnetic fields. These magnetic fields channel matter towards the magnetic poles of the star, where the hydrogen fusion reactions occur locally around the poles, creating an effect akin to a miniature thermonuclear bomb explosion. Although the intensity of these explosions is only about 1/1,000,000th that of a typical nova, their scale is still astonishing by terrestrial standards. A single micronova explosion can release energy equivalent to burning approximately 20,000 trillion tons of matter. To put that into perspective, this mass is roughly equivalent to about 3 billion Great Pyramids of Giza. These discoveries not only broaden our understanding of stellar phenomena, but also raise new questions about the evolution and life cycles of stars. The new findings concerning micronovae have expanded astronomers' comprehension of stellar explosions. These discoveries not only add to the list of known types of stellar explosions, but also suggest that explosive stellar phenomena in the universe may be far more diverse and abundant than we previously thought. This once again confirms that the universe is a place full of energy and always harbors unexplored mystery. Astronomers suspect that these micronova events may not be so rare in the universe. However, due to their fleeting nature, observing and recording them becomes extremely challenging. To detect more of these elusive events, large-scale surveys with rapid response capabilities are needed. Scientists believe that with the development of technology, especially new generation telescopes coupled with advanced equipment, we will have the opportunity to explore the mysterious microphenomena in the universe in greater detail. Beyond the discoveries of stellar phenomena, we've also identified numerous exoplanets in the Milky Way galaxy. Some of these planets reside within the habitable zone, possessing conditions similar to Earth and potentially supporting life as we know it. Conversely, some planets orbit incredibly close to their host stars, resulting in scorching temperatures like fiery hells. Other planets are located so far from their host stars that they are nearly frozen solid. However, there is one particularly unique type of planet known as a rogue planet. Rogue planets, also known as interstellar planets, are, as the name suggests, planetary mass objects that do not orbit any star. They move freely through interstellar space, unconstrained by the gravitational pull of any star system. There are several different hypotheses about how rogue planets form. Some scientists believe that they may result from powerful gravitational interactions within young planetary systems, causing some planets to be ejected from their orbits. These planets then become wanderers in interstellar space. While our knowledge of rogue planets is limited, scientists have proposed several hypotheses regarding their origins. It's possible that they are failed stars, celestial bodies that lacked sufficient mass to become stars, or planets ejected from their original planetary systems due to strong gravitational interactions with other celestial bodies. Observing and detecting rogue planets presents a significant challenge because they do not emit light. Even if their cores generate heat and emit infrared radiation, this radiation is too weak to be easily detected using conventional methods. A significant breakthrough occurred in 2011 when scientists first confirmed the existence of an interstellar planet using gravitational microlensing. Based on these observations, they estimated that there could be tens of billions of rogue planets in the Milky Way. However, to date, only 19 potential rogue planets have been discovered, with only 2 being definitively confirmed. PSO J318.5-22 was the first confirmed rogue planet. This celestial body was discovered in 2013 through images captured by the wide-field camera on the Pan-STARRS-1 telescope. It is located approximately 80 light-years from Earth, is about 6 times the mass of Jupiter, and is classified as a giant gas planet. Surprisingly, this planet is shrouded in a layer of hot, dusty clouds and molten metal. The temperature inside the clouds is estimated to be over 800 degrees Celsius. This discovery may alter our imagination of rogue planets, which are often thought to be frigid and dark. Another oddity is the age of this planet. Various research teams have estimated PSO J318.5-22 to be only about 12 million years old, a very young age on a cosmic timescale. This raises the question of how such a young planet came to be a wanderer in space. Scientists hypothesize that, after its formation, possibly from a planetary collision, PSO J318.5-22 was quickly ejected from its original planetary system by the gravity of a larger celestial body. This suggests that the formation and development of planetary systems may be more complex and unstable than we previously thought. More recently, in 2016, a new potential rogue planet was discovered named SIMP J013656.5+093347. Initially, scientists thought it was a failed star, also known as a brown dwarf. However, it is now believed that it may be a giant gas planet of enormous size. Brown dwarfs are celestial bodies with a star-like composition, but lack sufficient mass to trigger nuclear fusion in their cores. Specifically, they have a mass less than 0.8 times the mass of the Sun. Brown dwarfs are considered an intermediate type of celestial body between the heaviest giant gas planets and the lightest stars, and are often referred to as substellar objects. SIMP J0136 is located in the constellation Pisces, 1995 light-years from Earth, and has a mass of 12.7 times that of Jupiter. Its size lies right at the boundary between a planet and a brown dwarf. Typically, astronomers define the mass of a brown dwarf as being between 13 and 75 times the mass of Jupiter. A notable feature of SIMP J0136 is that it has a very strong magnetic field, with an intensity 4 million times greater than the Earth's magnetic field. This strong magnetic field creates incredibly impressive auroras on its surface. The rogue planet known to be closest to Earth is WISE 0855-0714, located in the constellation Hydra, 735 light-years away. It was discovered in 2014 through data from the Wide Field Infrared Survey Explorer satellite. Its mass is estimated to be between 3 and 10 times the mass of Jupiter. It is possibly a giant gas planet ejected from its original planetary system. However, some scientists suggest that it may be a low-mass brown dwarf, a type of celestial body believed to be more common in the Milky Way. Estimates suggest that there may be tens of billions of rogue planets roaming the Milky Way, raising the possibility that one of them could enter our solar system. Some scientists even believe that this may have already happened and hypothesize about the existence of an undiscovered planet 9 in our solar system. The question arises, if a rogue planet were to enter our solar system, what would happen? This is a complex and interesting topic.